Hi, we're Group 4 and we're working on a remote water quality testing device. I'm Erica, this is Doug, Chris, and Eric. So a lot of communities that don't have access to city water are responsible for testing the safety of their drinking water. And the device that we're creating is going to solve that problem because a lot of the devices already on the market aren't marketed towards individual households and they're too expensive. Our device is going to be cheaper, more affordable for individual households, and it's going to test the turbidity, pH, temperature, and ORP of the water. It's going to automatically upload that data onto the internet so that they can view that data at any point. And if the parameters become unsafe, it's going to automatically notify them that they need to have their water tested to ensure its safety.
So the way we're implementing our design right now, it has two different subsystems in it. The first subsystem is a microcontroller unit. And this right now is just out in the open, but in the future we're going to make our own printed circuit board, and we're also going to make our own enclosure for it. It needs to be weatherproof, and it's also going to be mountable on the outside of the cistern. So this device communicates with the sensors right down here. And so you'll see we have temperature, pH, ORP, and turbidity currently. So inside this weatherproof container, it communicates with an ADC, an analog to digital converter. It goes through a serial connection to the MCU. And the MCU communicates the data via Wi-Fi to the user. So right now, one of our major design challenges was that we needed to make sure our system would operate near water, basically inside water for long periods of time. So right now our sensors are not rated for long-term use. So what we plan to do is we need to get better sensors, and we're also going to develop a better enclosure so that it's going to be weatherproof. It's going to be a polycarbonate case with precision drilled holes that have O-rings fitted inside them so that the user can easily replace sensors that may have failed.
So one thing we learned about product development was that most of the time, the first time you're not going to get it right. We built PCBs in our Makerspace lab, and I think we went through maybe 4 or 5 different designs. Just learning the material, learning how to use different programs, learning how to use the machines. It actually took a few of us to understand how to use this equipment, not just one person. So it's really a team effort on learning how to use those PCBs. So as far as the enclosure and stuff, we've all been working on that, rolling around some ideas. We've gone through maybe 4 or 5 designs of enclosures to put in the water to house the sensors. And so this has really been one of the challenges as well for us. But that's it on product development.
So right now we have the microcontroller and it's talking to the laptop. The microcontroller is making its own Wi-Fi connection that the laptop connects to and is constantly sending data to the laptop, which is being displayed on these graphs. The sensors are connected over this cable, and the information that they're picking up is sent digitally over the cable. When it's finished, the sensors are going to go inside the cistern like this, and the wire is going to come out of the cistern and the microcontroller is going to be outside. It's going to connect to the user's Wi-Fi instead of having its own Wi-Fi that the user connects to, and it'll upload the data to the cloud where they will be able to access and see if they need to get their water tested. That's dirty water. So we can put it in some dirty water if you want to see that. And we should be seeing some changes. This water's a lot colder. That water's warm,